Okay, so hi and welcome. Can you hear me?
Yes.
Okay, so just we're waiting 1 or 2 minutes for joining all of those other participants, then we'll start. Okay, so in the meantime, I also try to discuss about our upcoming online training program, which will be held on the 13th October 2023, and our admission last date is the 11th October, and this is the booking last date. And in the meantime, we have also provided first 10 registered people get the 50% discount on this online training program. And now the available discount seat is only for the 5. If you want to join this online training program with the 50% discount, so as soon as possible, you can simply confirm your seat and join our Google Classroom and also join our WhatsApp group. So basically, this is the total 7 days online training program, and it's mainly for the 7 days of complete Google Earth Engine online training program for remote sensing and GIS analysis for beginners to advanced level. And mainly class will be taken for the Friday and Saturday in a week. Class duration is the 3 hours and English mode. And then mainly in this online training program for booking your seat, you can simply contact with this WhatsApp number, as well as you can also contact with this email. Okay. So basically in this online training program, we just focus only for the beginners who don't have any knowledge about that Google Earth Engine, or who don't have any knowledge about the remote sensing, or who don't have any knowledge about that programming language. Don't worry about that. In this online training program, we focus only for the beginners who don't have anything about the JavaScript programming, Python programming on Google Earth Engine. So basically, we cover the land use, land cover, change detection, land use, land cover mapping using the machine learning method. We talk about the air quality monitoring, time series analysis, calculating any indices, supervised, unsupervised classification, different types of machine learning method, lot of things we try to cover in this online training program. And here you can see all of this course content about that. So you can see all of this course content. I add all of this information in the video description. From here, you can easily get all of those things. Okay. And you can easily get the course benefits, such as you can get the course e-certificate after completing all of those assignment. You can get all of those materials such as slide, PDF, practice code, recorded video class is also available. And you can also get the lifetime teaching support. When you face any problem regarding any issue or code, you can easily get the support from me. Okay. So if you want to join this online training program on which held on the 13th October, just simply contact with this WhatsApp number, as well as you can also contact with this email. Okay, thank you. Okay, so now we'll start our today's session. Okay, so basically today is our fifth number of class, and mainly today I try to discuss about the air quality monitoring, how we can easily monitor the different types of air quality parameters such as nitrogen dioxide, sulfur dioxide, methane, as well as also carbon monoxide. So these type of air quality parameters, how we can easily monitor using Google Earth Engine, okay, as well as different types of analysis for that air quality parameters. Okay, so now let's jump over to this class. I simply share my screen. Okay, now can you see my screen? Is it visible?
Yes.
Okay. Okay, so let's. Okay, so basically this is our today fifth day's course content. So basically, not only for the nitrogen dioxide, sulfur dioxide, any kinds of other parameters such as carbon monoxide, methane, anything we can easily extract the different types of density map, different how we can easily download the air quality parameters time series data in CSV file format using Google Earth Engine, how to convert the unit from mole per meter square to molecule centimeter cube, and how to make time series chart of the air quality parameter, how to export this map and use ArcMap software, as well as how we can easily calculate it, the total emission of any particular gases for a specific region. Okay, so let's go. So first of all, you can see these two type of map here. You can see one is the showing the methane concentration map of Kuwait. So basically it's the methane concentration unit is the ppb, and this is the another map for the nitrogen dioxide concentration map year of 2020 month of January. It's the another unit mole per meter square. This is the value about that. It is a low value inverse 505. You can say high value about that. Also you can get the high value, this type of red color identify the more emission of methane for this Kuwait, and low we can get this type of low about that. Okay, so basically this type of analysis or this type of monitoring for the different types of gas, methane or nitrogen dioxide or carbon monoxide, this type of gas we can easily access the information from the Google Earth Engine using the Sentinel-5 satellite imagery. Okay, so in this time we are used here the Sentinel-5 satellite imagery and show you that how we can easily use the Sentinel-5 satellite imagery and then make this type of map, and also time series chart, how to download the data in time, CSV file, and how to calculate it for the total emission of nitrogen dioxide or total emission of the methane for any specific region. Okay, so you can see this is another tax about the nitrogen dioxide level rebound in Bangladesh for the different time period, before lockdown, pre-lockdown, during lockdown, post-lockdown, and we are also classified very low, low, medium, high, and very high. Okay, about the concentration of the nitrogen dioxide for the different in the COVID session. Okay. So in this time we talk about the air quality monitoring using the Sentinel-5 satellite imagery. So basically Sentinel-5 is focused on air quality and composition of climate interaction with the main data product being ozone, nitrogen dioxide, sulfur dioxide, formaldehyde, aerosol, carbon monoxide, methane. This type of gases we can easily access from the Sentinel-5 satellite imagery. And here you can see this is the link about the Sentinel-5 satellite imagery. So you can simply copy the link and open in a browser. We can easily access the Sentinel-5 satellite imagery. As well as you can simply open your code editor. Suppose I simply open a code editor and then simply browse data catalog. From the top of the code editor, we can also get the search bar. From this search bar, we can easily access all of those data. Just you can see the search place or data set. Simply click on, you can see browse data catalog. Simply click the browse data catalog. Then you can easily access all of those data from the Sentinel. Just click on the Sentinel. Okay, so after that, you can see in this time we are talking about the Sentinel-5 satellite imagery. So in this time, Sentinel-5 satellite imagery, it is a tropospheric monitoring instrument. So basically from that we can easily access all of those air quality parameters such as aerosol, cloud, you can see the carbon monoxide, formaldehyde, nitrogen dioxide, then ozone, also the sulfur dioxide, methane. Okay, so this type of gases we can easily access from here. So now all of those data set is the same approach for filtering, for also make the time series chart. Okay, we can easily apply the same approach for filtering or displaying the result or making the time series chart or calculating the how many gas is emission in a particular time or in a specific region. Okay, this type of analysis we can let's do all of those data set. Okay, so let's go. First of all, suppose in this time I want to work for that nitrogen dioxide. Okay, just simply click on the nitrogen dioxide. So now I can access all of those nitrogen dioxide gases information, data set availability. Basically we can get the data from year of 2018 to 2023.
Hello.
Yeah, please.
Sir, sorry for out of box. I'm asking one question.
Yeah,
So
please.
nowadays, drone data is much more high resolution data is available nowadays outside
Yes.
drone data. So is it possible to we can apply these codes or this type of scripts to
Yeah, we can also apply.
outside
Yeah.
data?
Yeah. Suppose,
Is it
but
possible, sir?
yeah, it's also possible, but your image format will be TIFF format, such as
Okay.
export
Then we
image.
have to.
Yeah.
Okay, then we have to access that path. Then we have to use it.
Yeah. Then we also use of all of those Google Earth Engine server function on these TIFF images and make the
Uh,
lot of analysis using the high resolution satellite imagery or drone images. It's also possible to use the Google Earth Engine platform using the drone image. The same
we are
process.
giving our input as an
TIFF image.
GeoTIFF format.
Yeah, GeoTIFF format. Yeah.
Okay.
Then we can
The
easily apply.
second thing, sir, is it possible to say it is? I think we have to suppose our own sensor, like in every Senji, some sensors are there.
Yes.
So that data also we have to possible, sir. Means
Yeah.
possible means we have to give again TIFF format only.
Yeah, TIFF format. Yeah. Because Google Earth Engine
Oh,
is only supported for the GeoTIFF
uh,
TF record. This type of file is only supported. Okay.
okay.
We
Okay.
can simply
Okay.
convert and then
Thanks.
try to use it. Then we can also get a better result about using the drone images for the different types of analysis. Okay. Okay. So now here you can see the dataset availability about that this time period we can get the data. And dataset provided is the European Union, ES Copernicus, and this is the unique idea about the dataset. And all of this information we can easily access from here. This dataset is the resolution you can see 1113.2 meter. And this is a description about the dataset, how it will be work about that, or create the dataset. We can get the information. You can see bands, nitrogen number, column number, density. So it's a band about that when you want to work for the density map. Also, you can see another band is the different types of phase. You can see the tropospheric phase, stratospheric. Okay. So in this time, which band you want to need, simply work with that. In this time, I want to work for that nitrogen number, column number, density. I want to make the density map of nitrogen dioxide. So that's why I simply use it. And mainly it's the, you can see the ratio between the slant column density of nitrogen dioxide and the total air mass factor. Okay, this is the ratio they're used for the total vertical column of nitrogen dioxide. And it's the density of the nitrogen column number density. Okay. So now we are use the data set. We can get the unit is the mole per meter square. Okay. So in this time, this data set I want to use and make the different types of analysis. Okay. So first of all, I need to import the data set. Just I simply copy from here. Copy. And then paste. Okay. Then I simply paste. Then give a variable name. You can put any variable name. Suppose I put the variable name is that I take the var keyword and put the variable name, suppose data set. Okay. So this is my data set or image collection. You can see it's image collection. So now this image collection, I need to filter according to my region of interest, according to my band, specific band, because it is a lot of band. You can see this image collection including lot of band, but I want to work only for this band. Just I simply copy this band name or which band you want to need. Simply use a function select. So now from this image collection, I select only for the specific band of nitrogen number, column number, density. Okay. So now this image collection is available for the year of 2018 to present time, but I need the result for a specific time. So for that, I simply use another function, filter date function. Filter date function. I put the date such as 2020, suppose 1st January. Suppose I also put here the date. Suppose I do observe the result for 2020. Suppose 1st January 31. Okay, month of January, year of 2020, and to check the data. Okay, so in this time here you can see image collection, select, and filter date. We are also applied another function. So basically this select, filter date, is the must we need to use, and another is that filter bounds. Okay, so filter bounds function for a specific boundary, which boundary you want to need the data set. So suppose in this time I need to observe the whole country boundary of Bangladesh. Okay, what is the condition of the nitrogen dioxide month of January 2020? Okay, just I simply import the boundary of Bangladesh, whole country boundary shapefile, and give the variable name such as a ROI. You can put any variable name. So now I filter bounds with my ROI. This is my shapefile, which is stored in the shapefile. So now you can see here, I just simply this image collection, I filter, choose the specific band, and also filter a specific time period, and also a specific region of interest. Okay, so now it filtered. So now if you want to check how many images is available, so just simply use a print function, and then copy the data set and use a function here, use here the size function. Okay, so now it counting or computing how many images is available in the data set. Okay, so we can get the 424 images is available for this data set. And if you want to check, suppose acquisition time about the data set, just simply copy and then data set you can see. Click to that. In this time we can get all of those data with their time. So here you can see total 424, and here we find out all of those images with their time. You can see the 1st January. You can see lot of data set only for the 1st January. You can see 1st January. You can see. Then we can get the lot of 2nd January. You can see 2nd January. Then 3rd January. Then you can get the 4th January. So in this time, all of those data, I just make a average result. Suppose I want to calculate the average. I want to calculate the average from total 424 images. So just I take a variable. Suppose I put the variable name is that average, suppose NO2. Okay, just I put the variable name is the average NO2. And then simply call my data set, because average 42, this is my image collection. Just I simply copy and then paste here. In this time, if you want to, you can use here the mean function directly. Then it also calculated the average result. Or if you want, you can also use here the reduce function. And then how I can reduce Earth engine reducer dot mean. Same approach. Okay, we can get the same result. So there's a two way. If you want, you can use here the reduce, and then how we can reduce reducer dot mean. Or if you want, you can directly you can use here the mean function. Okay. So now it calculated the mean result. Okay. So you can simply print that. You can simply print. In this time, it create only for the one image. You can see I simply copy and then print that. In this time, it create the single image. Okay. And this single image has a single band, because I use here the only for the specific band. Okay, this is my nitrogen number, column number, density. This is my specific band. Okay, this single image contains only for the specific band. Okay, this is the specific band of this image. Okay, so now this image I simply clip with my boundary shapefile. So use here the clip and then call the ROI. Okay, so mainly this clip function is only work for the image. Okay, clip function is not work for the image collection. Okay, so in this time you can see I just simply reduce it and make an image. Mainly it's the average pixel value of nitrogen dioxide only for the one single image. So now I can simply apply the clip function. That is no problem. But without mean, suppose I can simply use here the clip function, use here the clip function and clip with ROI. Then it will be don't work, because clip is only work for the image, not image collection. In this time, when I use here the image collect, you can see image collection, select filter date or filter bounds. Here I can get total 421 images. Suppose it's a image collection. Okay, so it's a image collection. So image collection is not work for the clip. Clip function is not work for the image collection. So when you want to use the clip, you must make the image or single image. Okay. So when I calculated the mean result, then we can get only for the single image. We have contents only for the one band. So now this is the image. I can easily use the clip function and clip the image for my study area of Dhaka city. Oh, sorry, of Bangladesh, whole country boundary of Bangladesh. So now let's go, we display the result. So for that, use the map dot add layer function and call the average this variable, and also focus the center of the shapefile. So use the map dot center object with ry and put here the suppose 10. Click to the run. In this time, we can get this type of result because we did not add any types of visualization. Okay, so in this time we just simply added the visualization. For that, I simply click on here, and you can see that already create this type of visualization. Just I simply copy it from here with their color plated. Simply copy and paste here. And then simply copy the variable name and paste after the object name. In this time, it will set the color. Okay. So now this red color is identify the highest concentration or maximum concentration of the nitrogen dioxide. So mainly nitrogen dioxide, it is the main source of human activities such as fossil fuel, coal, gas, and oil. Okay, fuel used in cars. Okay, so that's how we can get the lot of concentration of the nitrogen dioxide. Also, you can get in here, very small also in here. Okay, so this result is only for showing the month of January 2020. Okay, we can get this type of result. So now from here, you can simply check the result. You can simply get the how for each specific coordinate. We can say the result. You can say specific coordinate. What is the pixel value or what is the how much you can see we can get the result. This is the mole per meter. This is the mole per meter we can get for this. Okay. Suppose you can check the another. Simply click on here. You can get this value about that. Okay. So basically, this is the process for visualization the map. How we can easily visualize the air quality parameters map. Such as you can see, not only for that, using the process, you can easily show the result for the other types of gases, such as also you can see the nitrogen dioxide. Also, you can see methane. Suppose I want to show the methane. Click the methane. I use the same code, just simply change the name, band name. Then it easily visualize about the methane concentration. So just I simply open any code editor. And after that, I can simply import the suppose for the Bangladesh region. And then give a variable name, suppose ROI. Then simply copy the same code from here. And then paste in the code editor. And now change the image collection. So in this time for the methane, this is the image collection. I simply copy that. copy the image collection from here and paste. After that, you have to select the specific band. So for the band, you can see they are already I want to work for that column number mixing ratio for dry air. Simply copy and paste. Okay. Suppose month of January, same date, same. Okay. We calculate the average and click with my study area. So now visualization, just I simply change the visualization. In this time I use this visualization. We copy and then paste in here instead of this code. So now click to the run. In this time it's showing the result for methane. So in this time here you can see it's showing only for this region which produce the methane. In this time we can get the some gap, this type of gap, because in this time, suppose month of January, we take only for the 1 year data. So 1 year data, it only extract the result. Only we can get the result for that. Suppose we can get the some emission in here, also emission in here. You can see only for this pixel for the Bangladesh, we can get the methane emission. Okay, suppose I can simply increasing the time period. Suppose year of 2000 January to suppose it's April. So now click to the run. In this time we can also get the lot of images on this time. Okay, so it was 30. Click to the run. So now it loaded all of those data set from January to April, all of those images. Now it create and then created the average result. Okay, so now I can see show the result about that. And mainly in this time you can see for the river, also you can see mangrove forest. Okay, there is a no value about that. So mainly methane is emitted from the variety anthropogenic or human influenced or natural sources. Anthropogenic emission source mainly including the landfill as well as also oil and natural gas system, agriculture activities, then coal mining, then stationary and mobile combustion, then watershed treatment, and there the certain industrial process is included for that methane emission. Okay, so for that we can see river, we did not get this type of pixel, also forest, in just we can get the result only for this region. Okay, for the emission of the methane. Okay, so this is the emission of the methane. Not only for the methane, using the same approach you can easily display any types of other map. Okay, so now I discuss about that how we can easily create the time series chart. Okay, suppose you can see I created this nitrogen dioxide map. So now from that I calculate how we can easily make the time series chart. Okay, and also download the data in Excel file. Suppose when the chart is not work, then we have to download the data in Excel file. Okay, so let's go about the time series chart. So for the using the time series chart, we can simply use a function UI dot chart dot image dot series. Okay, this is a function we can simply use. And then first of all make a dictionary. So curly bracket start and curly bracket in here. So first of all image collection. Okay, so mainly image collection, this keyword is that how many images you want to use for creating this mean image or average image. How many images you want to use. In this time we use here the total this image collection. You can see just by simply commenting that, and you can see how many images we use. So just print the data set and use the size function. So now it's showing how many images we are used for creating this type of average map. 424 images we are used. So this 424 is stored in this variable. So this is my image collection. Okay, I simply copy the image collection and use it in here for the image collection. Okay, so now it's not it. I simply remove that. Okay, and then region. Region is a shapefile variable name. In this time, shapefile variable name is that ry. Then reducer is that in this time I calculate the average result. So use at the ee dot reducer dot mean. Then scale. Scale is the resolution about the satellite images. This is the resolution. You can see what is the resolution is that 1113.2 meter. This is the resolution about that. Just simply copy and paste. Then X property. Put here the system time start. Okay. So after the